If you define the Big Bang really carefully as the time when the universe was very hot and very dense, and as I said, you can't argue with that because we can see it, because we can look out into the sky. Our best theory of how the universe got into that state is that there was a time before that, and it's called inflation. So the idea is the universe was there, in a sense, cold and empty and expanding extremely fast. And that expansion slowed down and stopped. And the energy that was driving that expansion got dumped into space, heated it up, and made all the particles out of which we're made. And that's what we call the Big Bang. So that's textbook. It's a textbook theory called inflation. It made predictions, some of which have been tested. Some incredible predictions, actually, about the way that galaxies are distributed across the sky, because they're not just random. If you look at the galaxies, they're in sort of flows and rivers of galaxies that cross the sky in a pattern called the cosmic web. And inflation predicted that before it was seen, actually. So it's an astonishing idea. And that theory has a kind of an extension called eternal inflation, which is that the inflation essentially goes on forever, and it just stops in little patches. So you imagine the fabric of the universe, space-time, stretch, and then it slows down and stops in little patches, and each one of those patches is basically a Big Bang and a universe, of which ours is one. So you end up with this sort of picture of an infinite fractal universe of basically an infinite number of Big Bangs, and that's called the inflationary multiverse.